Hello, functions in the real world. Functions are mathematical building blocks for designing machines, predicting natural disasters, curing diseases, understanding world economies, and for keeping airplanes in the air. Functions can take input from many variables, but always give the same output unique to that function. Functions also allow us to visualize relationship in terms of graphs, which are much easier to read and interpret than lists of numbers. So I can say that a function, let's make a quick note here, a function is a special relationship where each input has a single output, where each input has a single output. Some examples of functions include money as a function of time. So for the first one, money is a function of time. So time is my independent, so time is my input, money is the output. You never have more than one amount of money at any time because you can always add everything to give one total amount. By understanding how your money changes over time, you can plan to spend your money sensibly. Businesses find it very useful to plot the graph of their money over time so that they can see when they are spending too much. Temperature as a function of several different variables. It can be time of the day, the season, the amount of clouds in the sky, the strength of the wind, where you are, and many more. But the important thing is that there is only one temperature output when you measure it in a specific place. Location as a function of time. You can never be in two places at the same time. If you were to plot the graphs of where two people are as a function of time, the place where the lines cross means that two people meet each other at that time. This idea is used in logistics, an area of mathematics that tries to plan where people and items are for businesses. Let's look at a couple problems. For problem 1, which of the following relationships are functions and which are not? Explain your reasoning. For those that are functions, identify which of the two quantities depends on the other. For the first one, the number of miles driven in a car versus the number of gallons of gas used. So for A, number of miles driven So these are my variables and number of gallons of gas used. um, so now here I can look at it. So number of miles driven is dependent on number of gallons used. So here my input is number of gallons. This is your output. So this is a function because the number of gallons of gas gives a unique number of miles. Each input produces a unique output, and I can't repeat the input. B, um, price of a diamond versus the number of carats. So price depends on the number of carats. So my input is number of carats, and the price is my output. And so for each carat, there's a unique price that produces that it is a function. So A is a function, B is a function. The Major League Baseball player who has a certain number of home runs at the end of the season. Um, it says the identity of the Major League player depends on the number of home runs scored at the end of the season. It is not a function. Two or more players can have the same number of home runs. For C, it's not a function. Let me write this clearly here. The student who has a specific score on the SAT in a particular year. The identity of the student depends on a specific SAT score in a particular year. This is not a function because two or more students can have the same SAT score. The amount of rain falls on any particular day of the year in Seattle. So for E, I can say that the amount of rain is dependent on the day. So time is your input, output. This is a function. Um, each day has a unique amount of rain. For F, the day of the year on which given amounts of snow in inches fall in Buffalo. The day of the year is dependent on the given amount of snowfall, dependent on the amount of snowball. So my input and time is your output here. This is not a function because x can be repeated. There might be more than two or more days that have the same amount of snowfall. You know, when the input is repeatable, then it is not a function. So F, I'm saying it is not a function, again, because input can be repeated because two or more days can have the same output. That's the reason it is not a function. Problem 3. The following graph shows the noise level of a crowd. So noise level here is your output. Output is on the y-axis, basically on your vertical axis. Watching their school's basketball team playing at home in the championship finals. Match the three graphs with the corresponding scenarios. So I'm looking at the first one. It says that the team started slowly, so the noise level started slowly, eventually began to pull away. So started slowly, and there's some noise, and then pull away, got higher. And y-axis is your noise level. So started getting higher and higher. And B, we'll do the B later. Let's look at C. The score kept seesawing back and forth, but we finally won on a 3-point shot at buzzer. So when you've won at the final, the noise level is high. You know, the noise level is high. We already chose B, but then it says I'm doing C, right? It's like seesawing. So I started normal and then up and down seesawing and ended up with the highest noise level. So C, scenario C is graph I. D, our team started well, meaning high noise level, then the opposition took the lead, then noise level goes down, and then but we finally won high level. So for D, I would say the graph I. For B, it was a disaster from start to finish, meaning the finish, the noise level is down. So it doesn't fit any of the scenarios. So a possible fit could have been, I start normal and it was a disaster. You're up and down a little bit, but then you end up down. It was a disaster. This might be an option, one option of graphing. Problem 5. Sketch a graph of your distance from home as a function of time for each situation. Here you're going to assume either you live in the town or outside of the town and then draw accordingly. So if I assume home, my home is in the city. So travel towards downtown. So if I travel towards town, means I travel towards home. So based on that, let's look at A. I drove steadily across town, so that means I'm in the city around my home. So the distance of my home gradually increases, and I sped up as traffic diminished. So then the distance that I travel um, covers faster, and then and it, and then I'm on the highway. So obviously I start from home, so distance. So my y-axis is distance from home. That's my assumption. That's my output. I started from home, so drove a little bit steadily. I'm getting away from my home, and then I sped up. So um, the distance from home is farther away. B, I drove steadily towards town. So that means I'm getting closer to my home. So that means I'm starting from a I'm starting from away from home. I drove steadily toward town, but slowed down as the traffic increased. When I slow down, the distance I cover gets shorter. So let's do this. And then I inch toward around the car. Looks like I come to a full halt, and then the car had broken down before you could resume normal speed. And then normal speed, I go home, I reach home. For C, I drove steadily but realized I had left something behind. So I left home, you know, got away from home. Again, y-axis is distance uh, from home. So and then I realized I forgot something. I stopped, so I came back home. Distance is again 0. And then drove all the way to school without any further trouble. So distance gets higher and higher. It's not an arrow, obviously. Then I reach my work, my school. D, I drove steadily across town. That means I'm driving, away from home steadily. And then had a flat tire. So I waste some time. So obviously this is my time. So the distance is flat. I'm at the same distance spending some time. After changing it, I drove much faster. That means I cover more distance, go, I wasn't late for class, so then reach my class. Again, here y-axis represents distance from home. For all these problems. Now for 8, which of these values represent a function? So if I say for A, x is my input and y my output, if this is my assumption, x is not repeated, as you see 0, 3, 6, 1, 5, 2, 4, and so I can say here y is a function of x. Then y, the output, is a function of the input, and input, you know, x is not repeated, cannot be repeated. So if I look at the other way as y is my input and x my output, you see y is repeated twice, so the input cannot be repeated. So then I can say here that x is not a function of y, because y, my input, can be repeated. Let's look at B. If I say again x is my input and y is my output, then if I look at my x, it can be repeated, right? So y is not a function of x because my input can be repeated. Let's look at the other way. Y as my input and x as my output. So if I look at my input, 8, 4, 7, not repeated, so I can say x is a function of y. Thank you for watching. I'll see you with the next video. Thanks.